Welcome to this explainer. Today, we're diving into the absolute most fascinating cosmic mystery lurking right at the heart of our very own Milky Way galaxy. We're going to break down decades of intense astronomical sleuthing to figure out exactly what is sitting at the center of our galactic home. Right off the bat, we run into this massive, almost impossible paradox. I mean, how do you weigh and photograph a monster you can't even see? We're tracking a suspect located 26,000 light-years away, heavily obscured by these impossibly thick clouds of galactic dust. And because it's a black hole, it emits absolutely zero visible light. To optical telescopes, it's just a giant, dark, dusty wall. And yet, astronomers know exactly how heavy this invisible object is. It's 4.3 million times the mass of our sun. Let's put that into perspective for a second. Imagine taking 4.3 million of our suns and packing all of that mass into a spherical space that's literally smaller than the orbit of Mercury. It's totally mind-bending, right? It pushes the very laws of physics to their absolute limits. So, how did we figure this out? Let's get into part one, decades of clues. This whole investigation has basically been a generational relay race. It actually kicked off way back in 1933 when an engineer named Carl Jansky detected this mysterious, faint radio hiss coming from the direction of the Sagittarius constellation. Then, flash forward to 1974. Astronomers Bruce Spalek and Robert Brown linked telescopes together and pinpointed a highly compact, brilliantly bright radio source right at the galaxy's core. And from there, it took almost another 50 years to get the ultimate photographic proof in 2022. Now, you might be wondering about the name Sagittarius A star. Why the asterisk? Well, in 1982, Robert Brown officially named this compact radio source, and he actually borrowed the asterisk symbol from atomic physics. Over there, it's used to denote atoms in a highly energetic or excited state. Brown just wanted to emphasize just how exciting and intensely energetic this tiny radio source truly was compared to everything else around it. But, back in the early days, making bold claims about what this object actually was carried some massive professional risk. When Bollock and Brown first peered 26,000 light-years into deep space, claiming they'd found the very soul of the galaxy, a supermassive black hole, well, it seemed pretty brazen. Bollock later joked that at 30 years old, he really just wanted to make sure his claims passed the laugh test and wouldn't get him completely laughed out of the room by the senior scientists. Okay, moving on to part two, the stellar dance. Since the 1990s, teams led by Nobel Prize-winning astronomers Andrea Ghez and Reinhard Genzel spent decades literally tracking the footprints of fast-moving stars, known as the S-stars, zooming around the galactic center. By using infrared telescopes to pierce through that thick dust, they watched these stars move at just breakneck orbital speeds. The star S2 whips around at 5,000 kilometers per second, and it gets crazier. S4714 reaches an insane 8% of the speed of light at its closest approach. Tracking these orbits did what a photo couldn't at the time. It definitively weighed our unseen suspect. Because these stellar orbits proved that 4.3 million solar masses were crammed into a space smaller than Mercury's orbit, the suspect could realistically only be one thing: a supermassive black hole. And it had to be surrounded by an inescapable boundary known as an event horizon, where the gravitational pull is so fierce that absolutely nothing, not even light, can escape once it crosses that point of no return. So, this cosmic dance gave us the exact physical profile of our suspect beyond a reasonable doubt. We know it's about 26,000 to 27,000 light-years away in the constellation Sagittarius, packing those 4.3 million solar masses into a surprisingly tiny volume. The math was undeniably clear, but humans are visual creatures, right? We wanted a mugshot. Which leads us to part three, photographing the unseeable. The sheer scale of this challenge is honestly mind-boggling, because Sagittarius A star is completely dark and incredibly tiny from our vantage point. Taking its picture required a level of zoom equivalent to standing in your backyard and trying to spot a single donut sitting on the surface of the moon. Obviously, no single telescope on Earth could ever pull that off. To overcome this, scientists created the Event Horizon Telescope collaboration. They didn't just build one giant dish. They linked existing radio observatories across the entire globe to essentially turn the Earth itself into one giant virtual telescope. By capturing radio wavelengths that slice right through the galactic dust, and then spending 5 rigorous years processing that massive amount of data on supercomputers, they were finally able to reveal it. They didn't photograph the black hole itself, of course, but rather its shadow cast against the superheated, glowing gas swirling just outside the event horizon. And wow, when that fuzzy orange ring-like structure of Sagittarius A star was finally revealed to the world in May 2022, it was a moment of profound triumph for the scientific community. As researcher Mark Gorski so aptly put it when looking at the data, there is the thing that everybody's been looking for 50 years. Decades of theoretical math and invisible clues had finally culminated in direct visual confirmation. Now, if you remember the very first black hole image from back in 2019, the one in galaxy M87, you might notice they look remarkably similar. And this is so cool because it brilliantly illustrates the supreme power of Einstein's general relativity. Even though the M87 black hole is 1,000 times more massive than ours and 55 million light-years away, up close, both black holes produce that exact same characteristic shadow and ring. Relativity strictly governs their shapes, proving that physics scales perfectly from our local neighborhood out to the deepest reaches of the universe. Let's look at part 4, a sleeping giant. So we've identified and photographed the monster, but what's it actually doing today? Well, despite its terrifying reputation, our supermassive black hole is currently what astronomers call quiescent. Basically, it's a sleeping giant. It survives on a diet of gas and dust so remarkably meager that if you scaled it down to a human being, it would be the equivalent of eating a single grain of rice every million years. Because it eats so little, it emits way less radiation than the brightly blazing active black holes we see in other galaxies. However, sleeping definitely doesn't mean dead. For half a century, scientists suspected that even quiet black holes must blow away some material, a so-called black hole wind, but they just couldn't find it here. But recently, the ALMA Radio Observatory mapped the cold gas near Sagittarius A star and found this massive 3-light-year-long cone-shaped cavity. That cavity was undoubtedly carved out by a hot wind blowing from the black hole, pushing the cold gas away. It proves that even when starved and quiet, this ancient giant still exhales, violently reshaping its immediate environment. Which brings us to a really compelling final thought. We are safely orbiting 27,000 light-years away from a starving, relatively peaceful monster. But, galaxies are dynamic. Gas clouds fall inward, and stars occasionally stray a little too close. If our galaxy's dark heart is currently just a sleeping giant, what on earth will happen to the Milky Way when it finally gets a real meal and wakes up? As new telescopes come online, we'll keep watching the center of our galaxy, waiting to see what secrets this cosmic beast reveals next.